Hey guys, today we're going to discuss Codeforce round 381, division 1, problem B. Alright, so as always, let's introduce this problem by explaining the example. So here is the example, right? 5 is the number of nodes in the tree. And the following line is the value of each node: 2, 5, 1, 4, 6, right? It's the value. So the following several lines are the edge's value, right? It's the second node's parent is node number 1, and its value is 7, right? And the third node's parent is also number 1, and its value is 1, right? So etc. And its output is n numbers. In this case, it's 5 numbers, and each of the number says the number of nodes it controlled. What is the control mean? So the control means the controlled node is U here, and the controller is V here, and the value of the controlled node is greater or equal than the distance between the controller and the controlled node, right? So for example, if we are going to find the number of controlled node of this node, we will first find out if this node is being controlled, right? So its value is 1, right? And the distance between these two nodes is 1. So this node is being controlled by this node. So the number is 1, right? Because no other nodes satisfy this condition, right? Let's see this node. This node value is 5, and their distance between them is 7, right? 7 is bigger than 5, so this node is not controlled by this node, right? Let's see other one. Is this node controlled by this node? Let's see. This node's value is 4, but the distance between them is 6. So this node is also not controlled by this node. Okay, let's see this node, right? So which node is controlled by this node? So let's iterate all its children, right? So this one's value is 4, and the distance between them is 5, right? So let's make sure we have recorded the audio, alright? Looks good. So 5 is bigger than 4, so this node is not controlled by this node. So we move on. Is this node controlled by this node? So its value is 6, and the distance is also 6. So condition is satisfied. So this node is controlled by this node. Okay. I guess the return value is 1, right? So how do we solve this problem? So let's make a little change to this condition, right? So distance between two nodes equals to the distance of one node minus the distance of the second node, right? The distance here means the distance to the root node. So D4 here is 6, right? Because it has the 6 to the root, right? And D6 here equals 7, right? It has 2 edge to the root, right? And this distance is 1, right? So what's the distance between 1 and 4, right? So the distance is 6 minus 1, which is 5, right? So we got this condition instead, and we make a further change. Move this item to this side and move this item to this side, right? So on the left side we have a formula about u, right? And on this side we have v, right? So in this case, if we run a DFS and let's say we are now DFS this node, right? So this node is u, and we know its value and also its distance to root. So we can know the value of the left side, right? And we need to find the nodes that control this node, right? So we only need to do is to find all the nodes that the distance of that node is bigger than this value, right? So we need to find the parents that the distance of those parents are bigger than a value, right? So what can we how can we do that? Let's simplify this problem, right? Because all we need to do is to find how many nodes that is its linear parent, and also their parent's distance is bigger than a certain value, right? So let's translate this problem to this problem, right? Let's say we have a u here, and all these nodes are u's linear parents, right? So in these parents, which of them distance are bigger than this value? So let's say these three, right? Why these three? Because if this node distance is bigger than the value, of course these two distance are bigger, because this distance this node distance is this node distance plus this edge's length, right? So this distance is surely bigger than this distance. So in this case, if we want to find the node's distance bigger than a certain value, we only need to find the first node that the distance bigger than this value, and the nodes after this node is surely also bigger than this value, right? So we can also be sure that the distance of this node, this node, this node, this node, this node are increasing, right? So we can use a binary search here. Binary search the first node that bigger than this value. Let's say it's this node. Then we can increase the counter of this three node by 1, right? How do we do that? How do we increase the value of a range of nodes by 1? So what we do is to use differential method, right? So we only change two values in this case. So we minus 1 here, and also plus 1 here, right? So we only record the difference, but not the actual value. So when we incursively solve this problem, we need to backtrack, right? When we backtrack, we do the subtraction and addition, right? In this way, we can get the values of each node, and when we backtrack, we pass the values to its parent, right? So we add the value of this node to its parent when we backtracking, right? So let's see the code. Here's the code, and in this part we read in all the values of each node, and in this part we record the children of each node, and this part we record all the parents of each node, and in this part we do DFS, right? And this value is the current node, and this value is the current node's distance to the root, right? So this part T is the first node that satisfy the condition, right? Satisfy this condition, right? We are at let's move it a little bit. alright, in order to see it clearly. Let's move it a little bit. Okay, that looks great. So P here is a U, right? We got a U here, and the V here, the smallest V is T, right? So if T exists, we can record, we can decrease its parent by 1, right? And increase P's parent by 1, right? And then we push it into the sorted array, right? In this array, in order for us to query the smallest node in the future, right? Then we do incursive call itself, right? And we add the value of its subtrees into its value when we backtracking, right? And we pop up this node from the sorted array when we down, right? And return the node's value. Okay, I guess that's it. Thank you for watching. You can find the link to the source code in the video's description. Alright, so have a great day.